Hi friends, I am Tanmay Kausalye. So today we are going to again start with the like physics. Okay, so in physics we have in the previous video seen about resistivity. In this video we are going to see resistivity only, but main points like its SI unit, then what will be its like proportionality and the formulas associated with resistivity and all such things that we are going to see. Okay, so firstly we will see what does resistivity mainly depend upon. Firstly, it depends upon the temperature of the substance. It is important. The two important things are the most important. Okay, that I am telling. Firstly, it depends upon the temperature of the substance. Okay, and second thing is the substance itself, its chemical uh, properties and all that. Electrons, how much electrons are they having, how much free electrons are present. Okay, so that's the like it depends. Resistivity depends on it. Okay, now it will be a very short video. Okay, so firstly let us do some revision. Okay, so about resistance. So resistance is proportional to length, and resistance is inversely proportional to area. This we all know. Okay. So by adding 1 and 2 we get a formula. Okay, not formula but a nice statement. When added with resistivity becomes a formula. That's the formula associated with the resistivity. Okay, so here we can write R, R is equals R is proportional to L by A. See, R is proportional to A. R is R is inversely proportional to 1 by A. Is proportional to 1 by A. Now R is proportional to L. So by adding these two formulas, we get R is proportional to L by A. Here I can tell you that R is proportional to L by A, but there's a problem. If you want to equate it, if you have seen my videos how to equate and proportionality, you will know about it. So we have to add a constant K or anything what you want. Okay, K, L, A. And by experiments, as I have told you before, by experiment we have found that K is resistivity. You know, resistivity, or you can tell simply as it has a specific resistance also, because resistivity and specific resistance are the same name and they are the same quantities also, only the names are. So R resistivity. Now we will not write symbol of resistivity. I will tell you now. Now here what will be the symbol of resistivity? Okay, this is a not an English alphabet. It is an alphabet of languages like it's an alphabet of Latin language. See how is it? I will show you. So 1 minute, I will draw it. This is the symbol for resistivity. Okay. So by this we can equate. See, resistance. This is another formula associated with resistance and resistivity too. Resistance is equal to resistivity multiplied by length by area. Okay, so not area by length. Most of the students get confused in this only. It is length by area. Okay, so now to calculate resistivity, now we can find a formula. Okay, now let's take it as alone the resistivity sign. A will be multiplied Ra by L. This will become R into A by L, because we are taking A to the left hand side. Okay, so we have to multiply. It is in division, so we have to multiply it. And L is in multiplication, so we have to divide it. Okay, so this formula is of resistivity. To find resistivity, and when these quantities are given like resistance, area, length. Okay, now let's find what's the SI unit of resistivity. What do you think? We will get by computing this formula only. resistivity equals to, now take for making any SI unit, so it is not an like SI unit which was already made. Like the basic units are meter, second, and all that. Okay, so they are not formed by mixing any two quantities, but this is formed by mixing three quantities. Okay, so here we have to make a SI unit by adding like by operating on the SI units which are needed by the formula. We can operate and we can find a new SI unit. Okay, so R. What is the what is the SI unit of resistance? It's ohm, correct? So ohm multiplied by what's the SI unit of area? It's meter square. What's the SI unit of length? It is meter. So operate on it. What do you get? Okay, so m is cancelled with this 2. It becomes like we can write this as pi into m. M square is m into m, and by 1 this m and m gets cancelled. Like this we can write it. Okay, so now simple, very simple. This is the SI unit, ohm meter. You can see it's ohm meter simply. Yeah, this is the SI unit of resistance. Resistivity. It is ohm meter. Okay, so by experiment we can find for the specific resistance or the resistivity of any material. The scientists do that things like they are special scientists for finding all these things. Okay, so the next point, resistivity is a scalar quantity or a vector quantity. For knowing more about these quantities and all that, you can watch my previous videos. I have explained all of the things. Do not directly watch. You can watch if you know, uh, because most people will know it. Okay, so resistivity is a scalar or vector quantity. Resistivity is a which quantity? What do you think? It is a scalar quantity because it's not associated with any direction. Here meter is coming, but meter does not define any direction. Yeah, it defines the distance or whatever the measurement, but not direction is not associated with it. Yeah, so that's why resistivity is a scalar quantity. Yeah. Now this was about the resistivity. Okay, so you can take a screenshot. Now further we will work on the numericals because I have made some numericals. I will show to you. See here, here resistivity numericals are there. This one. I have made them for you, and I have like worked on it. And okay, resistivity can also be like I will show you one thing. Here I have written. See, you see this thing? It will be better for the symbol because on the screen it's difficult to draw the symbol here. Yeah, you can see the symbol there. Okay, so you can take the screenshot. And what is the name of it? The symbol which I have told you, the name of it is rho. Like ABCD is there, so there this symbol is A. Okay, so we pronounce it as A. Here in English we pronounce this symbol as rho. Okay, so thank you. From the next video we are going to start with numericals. Stay tuned. Bye bye. Thank you. Study hard. Okay.